Dear students, today we are going to discuss about the concept of impulse and momentum from kinetics of a particle. First, let us define the terms impulse of a force and momentum. What is impulse of a force? When a large force acts over a short period of time, that force is called an impulsive force. Examples of impulse force. First example is in baseball. A ball struck with only a little portion of the bat does not make prolonged contact with the bat, resulting in a modest change in momentum or impulse, and the ball does not travel very far. If the bat strikes the ball squarely, however, the force is applied for a longer period of time, resulting in a larger change in momentum or more impulse, and the ball flies a significant distance. Second example of impulse force is firing of a gun. Third example of impulse of force is collision of two billiard balls. Now, the formula for impulse of a force. The impulse of a force, F, acting over a time interval for t1 to t2 is defined by the integral I is equal to integral t1 to t2 F dt. The impulse of a force, therefore, can be visualized as the area under the force versus time diagram as shown in the figure. When the variation of the force with respect to the time is unknown, the impulse can also be measured as I is equal to F average into delta t. Impulse of a force is a vector quantity and it has the unit of Newton second.
Now, what is momentum? If we consider the motion of a particle of mass, m, acted upon by a force F. The equation of motion of the particle is given by F is equal to m into A, which is equal to m into dv by dt, which is equal to d by dt of m into v. This equation states that the force F acting on the particle is equal to the rate of change of momentum of the particle. The vector mv is called the momentum or the linear momentum. It has the same direction as the velocity of the particle. The unit of momentum is kg meter per second or Newton second.
Principle of impulse and momentum. We know that F is equal to d by dt of mv. Multiplying both sides of the equation by dt, F into dt is equal to d of mv. This equation tells that the differential change in the momentum of a particle during the time interval dt is equal to the impulse of the force acting during the same interval. Integrating this equation from time t1 to a time t2. Integral t1 to t2 f dt is equal to mv2 minus mv1. If t1 is equal to 0 and t2 is equal to t, we can write mv2 minus mv1 is equal to integral 0 to t f dt. That means final momentum minus initial momentum is equal to impulse of the force. Which also means that the total change in the momentum of a particle during a time interval is equal to the impulse of the force acting during the same interval of time. The principle of impulse and momentum is particularly useful when dealing with a system of particles. For example, a gun firing a bullet. When a problem involves the motion of several particles, each particle is to be considered separately. We can then add vectorially the momentum of all particles and impulses of all the forces involved, and the equation can be written as sigma mv2 minus sigma mv1 is equal to integral 0 to t f dt. It can be observed from the above equation that when sum of the impulses due to external forces is 0, the momentum of the system remains constant or is conserved. That means sigma mv2 is equal to sigma mv1. That is, final momentum of the system is equal to initial momentum of system.
Now let us do one important problem. A gun of mass 3000 kg fires horizontally a shell of mass 50 kg with a velocity of 300 meter per second. What is the velocity with which the gun will recoil? Also determine the uniform force required to stop the gun in 0.6 meter. In how much time will it stop? Now let us solve the problem. Mass of the gun is given as mg is equal to 3000 kg. Mass of the shell is given as ms is equal to 50 kg. Let the final velocity of the gun is equal to vg. The final velocity of the shell is equal to Vs, and the force due to the gas pressure Bf. The gun and the shell may be considered as a system of two particles. During the short interval of time in which the explosion takes place, the force, F, acting on the gun and the shell, varies in an unknown manner. But it acts in the manner of action and reaction between the shell and the gun. Their impulses thus are equal and opposite. In the absence of any external force, therefore, the momentum of the system is conserved. Now, initial velocity of the gun is equal to 0. Initial velocity of the shell is equal to 0. Initial momentum of the gun and the shell is equal to 0. Call it as equation 1. Final momentum of the gun and the shell is equal to mgvg plus msvs. Call it as equation 2. Now equating 1 and 2. 0 is equal to mgvg plus msvs. That implies minus mgvg is equal to plus msvs. Which means that the velocities of the shell and the gun are in the opposite directions. Substituting the values. Minus 3000 into Vg is equal to 50 into 300. By calculating, we will get Vg is equal to minus 5 meter per second. The gun having a velocity of 5 meter per second is brought to rest in a distance of 0.6 meter. Using the equation, V square minus U square is equal to 2as, we will get 0 square minus 5 square is equal to 2 into A into 0.6. By solving we will get A is equal to minus 20.8 meter per second square. Now, force required to stop the gun is equal to mass into acceleration. F is equal to 3000 into 20.8, which is equal to 62,400 Newton. Now, let us calculate the time required to stop the gun. We know that V is equal to U plus AT, minus 5 is equal to 0 plus minus 20.8 into T. Therefore, T is equal to 5 by 20.8. Which is equal to 0.24 second.
Dear students, I hope this video helped you a lot. If you still have any doubts, write in the chat box. If you like this video, press like button, and share this video with your friends. If you haven't subscribed to this channel, press the subscribe button. Press the bell symbol to get continuous notifications of our new videos. See you in our next video. Goodbye.